Hello, everyone. Today we're going to learn about residual plots. It's the last plot we're going to learn about. So we're going to learn about what they are and how to produce them and what information they give us. So below is the data from our previous lessons, which represents the number of hours a student is studying and the grade they get on a test. And we have the scatter plot over here and the regression line. Okay, so this is the data we're going to use to create the residual plot. If you think of the word residual, it should remind you of another word, residue maybe. Residue is what's left over after you do something. If you cut a piece of wood, you'll have residue, for example. So it means the same thing here. So if you think about the grade, these are the actual grades, but the regression line approximates what the grades are. So you have two different grades here. You have the actual grade, and then you have the one that's predicted by the regression line. And the difference between those is your residual. Okay, so more specifically, the definition of a residual, for which we use the letter E, is the difference between an actual data value, which we call Y, and a predicted data value, which we call Y hat. So specifically, E equals Y minus Y hat. The value of Y hat is calculated by the regression equation, or the line of best fit. Sorry, that's not what I meant to do. So what we have here are the hours and the grades, which is basically a copy of what we had here. But now, according to this equation, we also have predicted values. So these are the predicted values. And to calculate the residual, we just subtract the predicted values from the actual values. So for example, here, 55 minus 56, that's -1. That's the residual. 60 minus 61, well, that should have been a -1 also. 61 minus 61, that's 0. 70 minus 66 is 4, and so on. Okay. So these numbers down here are called the residuals. Okay. It's kind of like the error, but error is always positive. So it's not exactly the error, but how much off the prediction is from the actual value. Now, just to go over these a little more, I'll explain to you again where they're coming from. So just to give you a clearer idea of what's happening. So here's the data. These are my X's and my Y's. If I go to my menu, I keep forgetting, you have to, when you do this, you have to be highlighting one of these headings. Otherwise, you don't get it. So stat calculations, linear regression. My X list is, I call that X. My Y list I called Y. I want to store this in F1. And here's my equation, slope, the y-intercept. When I store it in F1, what happens is if you go back to the home screen and you go to your graphs, so don't go to this graph, go to the home screen and then click on the bottom second app on the right. Go to tab, and actually, you know what? Let's not, I don't want to graph it. This will be easier, I just realized. So remember now, the equation is stored in F1. So if I wanted to see what the prediction is for, let's say, oops, wrong lesson. For when X is 4, I want to see what the prediction is. I know the actual Y value is 55, but the prediction is going to be 56. And that is when the calculator takes this X value and plugs it into the regression equation, it'll get that. But if you want to double check, you can go to F1 because that's where we stored it. So F1 of 4, we get 56. If you want to check F1 of 5, that'll be 61. So if you look, if you look at this, for x equal to 4, the predicted y value is 56. See, for all the 4s. For the 5, the predicted value is 61. So that's what these numbers are. They are the y values given by your regression equation. These are the real y values. Okay, so once again, the residual is the difference between y and y hat, the actual number and the predicted number. Okay, and what we're going to do next is we're going to graph the residuals. And on the y-axis, you put the residual values. So what I have here, I just took the x values and the residuals, and I'm going to make a plot with them, and that's called the residual plot. So when x is 4, the residual was -1. And when x was 5, I think the residual should have been -1 also, and I made a typo here. So let's correct it. So when x is 4, y is -1. When x is 5, y is -1. It should have been here, not here. Okay. It doesn't make a difference in the outcome, that one little mistake. When x is 5, y is 0. When x is 6, y is 4. When x is 6, y is 3, and so on. So I plotted all these points. And you notice that the residual plot has no pattern, meaning that the regression line was a good fit for the data. That's because if a line is a good fit for your data, that means that the points are pretty close to the line and they're scattered randomly, some above and some below the line. So basically what this is saying is that if the residual plot has a pattern, then the line of best fit does not approximate the data well. A nonlinear model would be a better fit, and we're going to see that in some of our next lessons. If the residual plot has no pattern, then the line of best fit does fit the data well. So let's see if based on what we just did, you can answer these questions. Okay. Which of the residual plots indicates that a linear regression will be appropriate for the data it represents? Well, we just said that if the residual plot is random, it is a good indication that the regression line is a good fit for the data. So that would be choice A, because if you notice, choice B and choice C have a pattern. They actually look like parabolas. Residual plot B tells you that regression equation was a quadratic regression and that it is appropriate for the data. We don't know that. The residual plot cannot tell you what that is. It just, all this tells you is that a linear equation does not fit the data well. That's all. Residual plot C shows the pattern needed to ensure a good linear regression fit. And that's also false. So that's pretty much it. Yep. Okay, have a good one.